Hey guys, Mr. B here again, bringing another math video. In this video, and this is actually trig derivatives part 2, I'm going to give you some examples of when you're doing trigonometric derivatives and you have to use a chain rule. So first of all, chain rule is this guy right here, y is equal to f prime of u times u prime. And if you didn't see my first video, you might want to check it out. In the first video, I talked a little bit about what happens if the trig derivative is your outside function. So it's your f prime you're going to find. Whereas in this one, I'm going to talk about it as if it's the inside function. So I think I might have did a couple examples in the last one where it was the inside function, but in this one I'm going to focus solely on that, especially if it's a root. So here are some examples of our trig functions, and you guys hopefully have seen these before, and if you want to, you can download the worksheet that's in the link below to get all these examples plus a few other ones and these trig derivatives that are here. Alright, so let's have a look and see what's on the go with this first example. So here I have y is equal to the square root of tan of x. So anytime I have a root, a lot of my students like to rewrite it as tan x all to the 1/2. So it doesn't really matter what's inside the root. The outside function is a radical, or a square root. The inside function is my trigonometric derivative. So that's what makes it a little bit different than if something was inside the tan and we were taking the derivative of it. So my my main part is actually a radical. So the square root, to take the derivative of square root or exponent 1/2, you have to take that at 1/2 down in front, and then we leave our tan inside. So it doesn't matter what's inside. So I tell my students, like, square root of something is 1/2 something to the, and we subtract 1 from the exponent, to the negative 1/2 times what's inside, the derivative of what's inside. So we need to know the derivative of tan of x. So that's where the trig derivative piece comes in. So the derivative of tan is secant squared. So we get 1/2 tan x all to the negative 1/2 times secant squared x. And that's it. That's my derivative. So, I can mess around with the arrangement of this. If my professor doesn't like negative exponents, I can rewrite it like this. So secant squared can stay in the top. I'll leave that 2 from the 1/2 in the bottom, and that can be square root of tan x. And there it is. That's all there is to it. So, it looks really intimidating to have that tan as your inside function, but it really doesn't make that big of a difference. Alright, let's try the next one. So the next one's actually a chain rule within a chain rule. So I have my outside function, my square root, and I have my inside function being my trigonometric function, sine. But then within that sine, I have something that's not x. So there's a u in this guy. So I have to be careful. I'm going to have to do this in a couple of steps. So the first thing I do is rewrite this guy. So sine of 3x all to the 1/2, just like that. So I take the derivative of that radical first, so 1/2 comes in front, derivative of sine of 3x to the negative 1 over 2. So I subtract off 1 using, that's basically the power rule, times the derivative, well, not basically, it is the power rule of 3x. Now, did I put that little line there? Sometimes I forget to do that. Yeah, I did. So now the derivative of sine of 3x, that is chain rule because of the 3x. So I'll take the derivative of that. Now you can do that in 2 steps or do it in 1 step. I'm going to do it in 1 step. I think by the time you're getting to here, hopefully you can do that in 1 step. And then the derivative of sine is cos of whatever's inside, times derivative of whatever's inside. So times derivative of 3x. And so you could write that like this if you really want it to. If it's something more complicated like a root, you might do that. If it's not, it's just 3x, take the derivative of that, it's just 3. So I get 3 over 2 sine 3x all to the negative 1 over 2 times cos 3x. And there it is. And again, if you don't like that negative half, drop it to the denominator. I'm not going to do it this time because I actually prefer it that way, but that's just my preference. Alright, last one. So the last one we have, really not that different than that previous one. The only difference being is now we have a root inside instead of a 3x. So it looks a little more complicated. We also have a cube root here. So remember, cube root is just cosecant, and I always try to write cos every time I do cosecant, x all to the 1 over 3. So it's, again, not that different. So y prime, so we do the outside function first, so it's the 1 over 3 out front. Cosecant stays inside, so, and then we subtract off 1, so negative 2 over 3 times the derivative of what's inside. Just like that. So now we have to take the derivative of this guy. So the derivative of cosecant x. So the derivative of cosecant is negative cosecant cotangent. So 1 over 3. And I'm going to get rid of the square brackets now. I'm going to go back to my round brackets. No reason why, it's just that's how I am. And then times, so the derivative of cosecant is negative cosecant. And we got to keep our root x in there. And then cotangent, root x, times the derivative of what's inside. So it's a little bit more of a complicated derivative. So it's a chain rule derivative. So therefore I have to take the derivative of what's inside. So it's a little bit more complicated, so I'll just list it like that now. I certainly could do it in one step, but I don't have to. So 1 over 3, I'm going to take that negative and throw it out front there. Cosecant, square root x, negative 2 over 3. Then cosecant root x, cotangent, oh, I did it again, cosecant root x, cotangent root x, and then the square root of that guy, so derivative of square root of x, 1 over 2 x to the negative 1/2. So let's see, I can combine this 1/2 and 1 over 3, so it's negative 1 over 6. These can combine, this cosecant and that cosecant, so I can add the exponents. So negative 2/3 plus 1 that's on this guy, so that's going to be just a third. So cosecant root x all to the 1 over 3. So those are gone, and then cotan stays by itself, cotan root x, and then times x to the negative 1/2. So again, if you didn't want that negative half there, you can throw it to the bottom, make a root x, put it next to the 6. And that's it, guys. That's a few more examples of some trig derivatives. Hopefully this helps you in your battle to conquer calculus. And remember, this is from one of my worksheets, so if you want to have a download of this guy, the link is in the comment box. And all these solutions, well, I'm up to number 6 now, so there are number 8, I guess. All these solutions will eventually be worked out, so they're good for your practice and hopefully help you have some success. Thanks for watching. Please share, like, subscribe, all that fun stuff. I'll see you guys in class. Thanks.